This is a video on proving diagonals are orthogonal. The question states, prove that the diagonals of a rhombus are perpendicular. The key to this proof is to sketch the diagram. So I have a rhombus, and I'm going to think of this rhombus as being a parallelogram generated by adjacent vectors u and v. Then the diagonals of this rhombus will be this vector here, which is u plus v, and this vector here, which is u minus v. Now, since this is a rhombus, rhombuses have equal length sides. So that tells us that the magnitude of u and the magnitude of v are equal. I want to show the diagonals are perpendicular, which means that these vectors are orthogonal. Vectors are orthogonal if their dot product is equal to 0. So I take the dot product of the first diagonal vector, which is u plus v, and the second diagonal vector, which is u minus v. Now the distributive property holds with dot products, which means I can multiply this dot product out and write it as u dot u minus u dot v plus v dot u minus v dot v. Now the commutative property holds with dot products. So u dot v and v dot u are equal. So negative u dot v plus v dot u is equal to 0. So these two middle terms zero out. And for the outside terms, if I take a vector and dot it with itself, I get the square of the magnitude. So u dot u is the magnitude of u squared, and v dot v is the magnitude of v squared. Well, that's good because the magnitude of u is equal to the magnitude of v. So the magnitude of u squared is equal to the magnitude of v squared. So when I subtract them, I just get 0. Well, that's good because when the dot product of two vectors is 0, that means those vectors, these diagonals, are orthogonal. And I can conclude that the diagonals of the rhombus are perpendicular. And I'm done with the problem.